Hello, I'm going to work through an example in this section 6.5 using the method of substitution for definite integrals. So this whole section is about evaluating definite integrals. And as I said before, substitution is the most commonly used technique in evaluate integrals, either indefinite integral or definite integral. We have seen some examples before on how to evaluate indefinite integrals using substitution. Here we just do an example of definite integrals using substitution, and the procedures are very similar to the problems of indefinite integrals, but we do need some extra steps, and I'm going to show the details in here as we work through the example. So, in here we have x squared as power function multiplied by a power function 2x cubed minus 1 to the fourth. We can FOIL 2x cubed minus 1 to the fourth. Just multiply 2x cubed minus 1 by itself. Also, you can multiply 2x cubed minus 1 by itself, and then multiply the result by 2x cubed minus 1, and then multiply the new result by 2x cubed minus 1. So here's the multiply 2x cubed minus 1 4 times by itself, in other words. And at the end, you're going to get the non-polynomial with different terms, and then you distribute the x squared to each term in the polynomial, and then integrate all the terms. Okay, but there's an easy way to do it if we use substitution, just like before. So the idea of substitution is to define a new variable. In here, we can define the new variable u as 2x cubed minus 1. Okay. So this is the part in the parentheses, and that's the part that makes some trouble for us. So in that case, we just define it as u, and that usually simplifies the situation. Okay, and then the next step is to find the du, as we did the differential of u, because we need to evaluate a new integral in terms of u. So everything has to be in terms of u in the new integral. We don't have anything of x in the new integral, including the differential dx. It should have been, it should be du's, we should not have dx, but we cannot change the problem, of course. So at the end, anyway, we will have du in the new integral. So let's see what the du is. So just like what we did before, we know the differential of a function is just derivative of the function times dx. Okay, it's not the derivative. It's a derivative times the differential dx, or the increment, whatever you call it, in x direction. We call it dx or delta x. But anyway, that's what we do. Okay, so now if you do the derivative of 2x cubed minus 1, you do it term by term. So you just multiply 2 with the derivative of x cubed. The derivative of x cubed is just 3x squared. If you still remember the power rule, you just put 3 in the front, and then subtract 3 by 1, so you get 2 as the new exponent of x. Okay, and then the derivative 1 is just 0, and at the end we need to multiply dx. So that's that, and then 6, 2 times 3 is 6, so we get 6 times x squared and dx. Okay, so now then so if you look at left hand side of this equation, you get du equals 6x squared dx. So the one thing we can do now is to just divide by 6 on both sides. All right, and we have a reason why we want to do that. Okay, as you will see later. So we got d over 6 equal to x squared dx. Or you can write it, x squared dx on the left hand side, that equals d over 6. Okay. So in here, I just divide by 6 on both sides, and I actually write, x squared dx on the left and d over 6 on the right. So we just switch left and right. Okay, that will not change anything. Okay, now, so that takes care of the u. Okay, and then one thing we need to do now is to find the value of u for the lower and upper limits of integration for x. So this is the extra step that we need to do, before plugging the numbers for definite integrals, and that's a step that is not included in indefinite integrals. So when x is equal to 0, so remember 0 is the lower limit of integration for the original integral, definite integral. So when x equal to 0, what is u? So you just plug in 0 for x, and okay, and evaluate it. Okay, so plug in 0 for x. Okay, so what do we get to u? So this, so that's 2 times 0 cubed is just 0, right? So 2 times 0 minus 1. So 2 times 0 is 0. So 0 minus 1, so that's -1. So why do we want to do that? Because at the end, we're going to evaluate the integral in a new format with the variable u. So everything will be written in terms of u. So the whole thing will not have an x. Then when you plug in the numbers, after finding the antiderivative, then you're going to plug in the number for u instead of x. Okay, so that's why we need the value of u for lower and upper limits of integration. Okay, because u is the new variable, and the new integral will be involving only u as the variable. So the lower and the upper limits of integration have to be of u. Okay, so then we just did the lower limits of integration, lower limit of integration for u. So when x equals 0, u equal to -1. And we can do a similar thing for upper limit of integration of x when x equal to 1. So that's the upper limit of integration. Okay. And Similarly, we just do it for 1 for x. So u equal to 2x cubed minus 1. That. So that's just 2 times 1 cube minus 1. So we know 1 cube is just 1. So that's 2 times 1. And the minus 1. Okay, we know 2 times 1 is 2. So 2 minus 1, so that'll be 1. So this gives us the upper limit of integration for u, the new variable, which is 1. Okay, so now we can rewrite the original integral into the new integral, okay, based on the new variable u. Okay, so let's just do it one by one. Okay, so first we can put 2x cubed minus 1 to the 4th in the front, and then we just move x squared to the back and multiply dx. And the integral is from 0 to 1. So, oh, what happens? Okay. So you can see now we can rewrite everything in terms of u. 2x cubed minus 1 is just u. So we got the integral of u to the 4th, isn't it? So that's u to the 4th. Okay, 2x cubed minus 1 is u, so we got u to the 1st, u to the 4th in the first term. U equal to 2x minus 1. Okay, and then x squared dx. And we already did that when we tried to do the differential of u. We got this identity. So x squared dx is just du over 6. So we can replace x and squared dx in here by du over 6. Right? Okay. But that's not the end. So we got the whole integral in terms of u. Okay. And that's why we, I want to do these steps. We want to find the relation between dx and du. Okay. Now, we also did the lower and upper limits of u based on x. So the lower limit of integration for u is -1. That's what we did in here. And the upper limit of integration for u is 1. Okay. Right. So these are corresponding to the lower and upper limits of integration for x. Okay, so now next we can do the integration. Now first we can factor out the fraction as 1 over 6. 6 in the denominator means it's essentially 1 over 6. So we can factor out from the integral and then just evaluate the integral now. So it's just the integral of u to the 4th from -1 to 1. And so now if we do that, we just follow the standard process. So to evaluate the definite integral, okay. So we find a antiderivative of the integrand u to the 4th. So u is the independent variable here. So if you still remember the power rule for integration, you just add 1 to the exponent, divide by exponent plus 1. Okay, so that's u to the 4 plus 1 over 4 plus 1 times. So that's the power of integration, and then we need to plug in the lower and upper limits of integration and subtract. Okay, so let's just write the notation here. So this is 1, this is -1. Oops, I'm going to plug in and subtract for you. So okay, let's see. So what we get is 1/6 times u to the 5 over 5, right? Okay, I guess I'm going to write one more step in here. So that's 5, 4 plus 5, 1 is 5. So we can change this whole thing to 5. Okay, and then these are the lower and upper limits of integration. Okay, so now let's just finish the whole thing. So 1/6 times u to the 5 over 5. So you multiply the denominators 6 over 5, you get the 1 over 30, and then you have u to the 5, on the top. 1 times u to the 5 is just u to the 5. Okay, right? And then now we can plug in on the -1 to figure out the final answer. Okay, so I guess we just plug in the numbers. So I'm going to plug in 1 for u in the first place as the upper limits integration, and then subtract -1 to the 5 over 30, the low limit of integration. Okay. Come on. Okay, so now everything becomes straight. 1 to the 5 is just 1. So we can just put the 1 on the top in the first term. Okay, it's a little slow. And -1 to the 5 is -1. You multiply negative number 5 times all the numbers. That becomes negative. So the next term is actually, the second term is -1 over 30. So, but you're subtracting the negative numbers, so that becomes plus. 2 negatives becomes a plus, so that becomes 1/30, 1 over 30 plus 1 over 30. So we got the same denominator, 30. So we just add the 1 on the top. So at the end, it's just the 2 over 30. By the way, you don't add the denominator. You keep the denominator. Okay, you just add the numerators. So we got 2, and we keep the same denominator. So it's 30. 2 over 30. We can reduce it to 1 over 15 if you just cancel 2 on the top and at the bottom. So that's the final answer for this problem.